Hello students, welcome back. Today we'll continue with exercise 7.8. Okay, so before starting, if you have seen all my previous videos, okay, if you like my videos, then please subscribe to this channel. Okay, in our last video, we had started with exercise 7.8 and we had completed the first three sums. Okay, now we'll move from the fourth one. Okay, so let's start with question number 4. So question 4 is integration of 1 to 4 x square minus x dx. Okay, so let me revise in short. We are taking lower limit as a, upper limit as b. So a is equal to 1, b is equal to 4. H b minus a by n. So 4 minus 1, so that is equal to 3 by n, or nh is equal to 3. What is our function? X square minus x. So what we are taking? We are taking f of a plus ih. So let's take here f of a plus ih. What is our a? 1 plus ih. So instead of x square, I will put 1 plus ih whole square minus 1 plus ih. So this will be equal to a plus b whole square, a square plus 2ab plus I square h square minus 1 minus ih. So 1 will get cancelled. 2ih minus ih, it will be ih plus I square h square. Okay, so this was the starting part. We have selected a lower limit, b upper limit, h b minus a by n h equal to 3, f of a plus ih, we got ih plus I square h square. So what was the formula integral? Limit h n lengths to infinity or h lengths to 0. I will take n lengths to infinity, h summation of f of a plus ih I equal to 1 to n. So this will be equal to limit n lengths to infinity summation of ih plus I square h square I equal to 1 to n. Clear? Now see here h as it is. IH. In that h is constant. Summation of I will be equal to n plus 1 by 2. Clear? Plus h square constant as it is. Summation of I square n plus 1 2m plus 1 by 6. Clear? So limit n lengths to infinity. I will multiply this h into h square. Now remember our technique, from both these I will take n common. So 1n and 1n, it will be n square and 2. So instead of n, 1. Instead of n, 1. Instead of 1, 1 by n. Plus h into h square h cube. Now n from all these three, 1, 2 and 3. So it will be n cube. Okay, and this 6. So now 1 plus 1 by n, 2 plus 1 by n. Clear? So now solving it, okay, I'm putting the value of n square h square, nh is equal to 3, and putting the value of infinity n, it will be 0. So this will be equal to n square h square 3 square 9 by 2. 1 into 1 plus 0 plus n cube h cube, that is 3 cube 27 by 6. So now 1, 1 plus 0, 2 plus 0. Okay. So this will be 9 by 2, 1 into 1, 1. 27 by means 3 twos are 6, 3 nines are 27. So again 9 by 2, 1 into 1 into 2. So it's 2. So 9 by 2 plus 9 by 2 into 2. So 9 by 2 plus 18 by 2. This will be equal to 27 by 2. This is your answer. Clear? See, I'm repeating the whole sum once again. See, it's 1 to 4 x square minus x. A1, B4, H, B minus A, f of A plus IH plus I square H square. So now using this formula, okay, f of A plus IH is this, H constant, I n n plus 1 by 2, H square constant, n m plus 1, 2m plus 1 by 6. Okay, now multiplying with h, so it's h square and h cube, taking 2 n common, n and n common, so n square, n cube. So where there is n, I am putting 1. When there is a constant number, divide by n. See, 1 is constant, 1 by n. 1 is constant, 1 by n. 2n, it's 2. Instead of n, I am putting 1 because I had taken it as common. And finally, removing the limit, we get 27 by 2. Clear? So just go through this question. Okay, now let's move to the next question. Question number 5. Integration of minus 1 to 1 e raised to x dx. Okay, before that, one formula that I had discussed in the last video, limit e raised to h minus 1 upon h, where h tends to 0 is equal to 1. We will be using this formula in this sum. Okay, so now let's start with our basics. What is a? Minus 1, b minus 1, h, b minus, sorry, b is plus 1, h1 minus 1 by n. So this is equal to 2 by n, or nh is equal to 2. Okay, f of x is equal to e raised to x f of a plus I h. This will be equal to f of what is a? Minus 1 plus ih equal to e raised to minus 1 plus ih. Okay, so this will be equal to e raised to minus 1 into e raised to ih. I have just separated this, e raised to minus 1 into e raised to ih. Clear? So this was a, b, h, nh, and f of a plus ih. So now our I is equal to, okay, limit n lends to infinity, okay, or h lends to 0. Clear? See, I will be using this formula here. So whenever there is answers questions like e raised to x, at that time instead of this I will take h lends to 0. Okay, because see, n lengths to infinity, that means h will be equal to 0. Both are same. So h summation of f of a plus I equal to 1 to n. Limit h lengths to 0. H, what is summation of sorry, f of a plus ih, e raised to minus 1 e raised to ih. So this will be limit h lengths to 0, h e raised to minus 1. Okay, that is constant. Summation of e raised to ih. So instead of that, I can write down e raised to ih means 1h means e raised to 1, or else let me write it down like this way, e raised to minus 1 into e raised to 1h plus e raised to minus 1 into e raised to 2h. Clear? E raised to minus 1 into e raised to 3h up to e raised to minus 1 e raised to nh. Clear? Or else I can also take e raised to minus 1 constant, h e raised to minus 1. Okay, it will be e raised to h, e raised to 2h, e raised to 3h, e raised to nh. Clear? So now see what will happen. This is a geometric progression. Formula for sum was a r raised to n minus 1 upon r minus 1. Right? This is geometric progression. Formula for series of n numbers in geometric progression. Okay, so what is your first? A e raised to h. What is your ratio? E raised to 2h upon e raised to h. This is equal to also e raised to h. So now I can write it down. Limit h lengths to 0, h into e raised to minus 1. Okay, now we will use this formula. Clear? So a, what is a? E raised to h. What is r? E raised to h. R raised to n. So e raised to nh minus 1 upon r, that is e raised to h minus 1. Okay, clear? So now limit h lengths to 0, this will be h by e, clear, into e raised to h. What is e raised to nh? What is nh? 2. So e square minus 1 upon e raised to h minus 1. Clear? Okay. So this will be equal to limit h lengths to 0, h. See, now this becomes the formula e raised to h minus 1 upon h. Right? So what I will do, e raised to h e square minus 1 upon e. Clear? Now I will take this h here, e raised to h minus 1 upon h. So this will be equal to 1. Clear? And then putting the value of h, e raised to 0 e square minus 1 upon e into 1. See, limit e raised to h minus 1 upon h, that is equal to 1. Instead of this h, I had put 0. E square minus 1, so e raised to 0 is 1. And this e, so this will be equal to e square minus 1 by e. So I will separate it. E square by e minus 1 by e. So this is e minus 1 by e. Okay, so this is your answer, E minus 1 by E. Clear? I'm repeating, this was the starting basic. Now when I have started from here, it's e raised to minus 1 into e raised to minus f. So putting value of 1 to n. Okay, so I only need to put the value 1 here. I can also take this e raised to minus 1 common before only. Okay, so I have not taken here. So we do minus 1, 1h, 2h, 3h up to nh. I have taken e raised to minus 1 common. Now this is a geometric progression. First term is e raised to h and the ratio is also e raised to h using this formula. Then I had made some rearrangement, e raised to h minus h, I had taken it as 1. Okay, you can directly also take it 1 from here. Okay, see if you want to finish it in short, if you want to finish it in short, then what you can do, see, e raised to h minus h, this is 1, just put down the value, h e raised to minus 1, okay, e raised to h, that is, sorry, not this one, this, e raised to h minus 1 upon h, that is 1, I am removing the limit, remaining is e raised to minus 1, e raised to 0, that is 1, nh, what is nh? 2 e square minus 1. So e raised to minus 1, 1 by e square minus 1, I will multiply it, e minus 1 by e. Clear? Okay, so just go through question number 5. Okay, now let's move to the next question. That is question number 6. Integration of 0 to 4 x plus e raised to 2x dx. Okay, so now there are two parts. One is x, another is e raised to 2x. So this will do based on the question 1, 2, 3, 4, and this will solve it according to question 5. Okay, now first let's see what is a, 0, b, 4, what is h, b minus a, 4 minus 0, 4 by n, that implies nh is equal to 4. Okay, what is f of x? X plus e raised to 2x. F of a plus I h. What is a? 0. So only remaining I h, that is equal to I h plus e raised to 2 ih. Okay, so this was about starting part. Now I is equal to limit n lengths to infinity h summation of I equal to 1 to n. I can also take h lengths to 0. F of a plus I h limit n lengths to infinity h. Now what is f of a plus ih plus e raised to 2ih. Clear? So this will be equal to limit n lengths to infinity ih. Okay, so h is constant. Integrate summation of I n n plus 1 by 2 plus e raised to 2ih means e raised to 1, 2 into 1 into h, 2h. I take I equal to 2, 2 to the 4h, 2 3 is a 6h. So finally e raised to 2nh. Clear? So now see what I will do. I will separate these two. I have to multiply this h here and this h here. So what I will do, limit, sorry, it's n lengths to infinity. N lengths to infinity, h into h cube, sorry, h square, n m plus 1 by 2 plus limit. Now when n lengths to infinity, that means h lengths to 0, right? When n is infinity, h is 0. So here I will use h lengths to 0. I will multiply this h here also. So h e raised to 2h, e raised to 4h, e raised to 6h, e raised to 2nh. Because n lengths to infinity implies h lengths to 0. Clear? Okay. So now see here, here we will take n common from this both. So h square n square. Here again Sn equal to a r raised to n minus 1 upon r minus 1. So what is our a here? E raised to 2h. And what is our r? E raised to 4h divided by e raised to 2h. Again e raised to 2h. So when I will solve it here, limit n lengths to infinity, okay, h square, n common, so it's n square. Again this 2 outside I'm taking. Okay, 1 plus 1 by n plus limit h lengths to 0 h. Okay, now what is a? E raised to 2h, r e raised to 2h upon e raised to, sorry, e raised to n minus 1, so it's 2h. So it's e raised to 2nh minus 1 upon e raised to 2h minus 1. Clear? So now in this case, putting the value of n square h square, what is nh? 4. 1 into 1 plus 1 by n plus limit h lengths to 0. Now say it's e raised to 2h minus 1. Okay, our formula is e raised to h minus 1 upon h. But here it's 2h minus 1, so I require 2h. So what I will do? Multiply by 2, divide by 2. Clear? So it's e raised to 2h, e raised to 2nh. What is nh? 4. So 4 to the 8 minus 1 upon 2 into, okay, say I have written e raised to 2h, e raised to 2 into 4, 8 minus 1 upon 2. So remaining is this 2, 2h upon e raised to 2h minus 1. This will be equal to 1. Okay, e raised to 2h minus 1 upon 2h. So now just putting here 2, 1 plus 0 plus e raised to 2h, putting the value of h as 0, it will be e raised to 0, e raised to 8 minus 1 upon 2 into 1. Clear? So 2 into 1 into 1, 2 plus e raised to 8 minus 1 upon 2, because e raised to 0 is e raised to 0, that is equal to 1, and this is also 1. So only remaining is e raised to 8 minus 1 upon 2. Clear? So now taking LCM, okay, 2 to the 4 plus e raised to 8 minus 1 upon 2. So this will be equal to e raised to 8 plus 3 by 2. Okay, let me just confirm it. And sorry, here we have made a mistake. NH is 4, so it will be n square h square 4 square 16. So 2 ones are 2, 8s are. So here it will be 8. So 8 to the 16 minus 1, it will be 15. So our answer is e raised to 8 plus 15 by 2. Clear? I'm repeating once again. These are two different types. Here we'll take n raised to infinity, and these are separated as h lengths to 0. Okay, so these are taken n common, and here we had used the formula for geometric progression. Okay, so just go through this question. Okay, okay. Now I'm solving one extra sum. Okay, that is different type compared to the two types that we had seen. We had seen two types. One was directly x square minus and that algebraic function, and another was about the exponential function. Okay, now we'll solve one sum of limit of a sum by this method of trigonometric function. Okay, so let's take one example. It's 0 to pi sin x dx. Okay, if you want to solve it simple, it's very simple. Integration of sin x is minus cos x. Put the value of 0 and pi. Minus cos 0 minus pi. Okay, minus cos pi. Clear? So that will be easy sum. But we have to solve it as a limit of sum. Okay, so now a is equal to 0, b is equal to pi. H is equal to b minus a, pi minus 0 by n, or nh is equal to pi. A function f of x is equal to sin x, f of a plus ih is equal to, what is a? 0. So f of ih sin ih. So our integral will be equal to limit n lengths to infinity or h lengths to 0, h summation of f of a plus ih I equal to 1 to n. This will be equal to limit n lengths to infinity h summation of I equal to 1 to n summation of sin ih. Clear? So this will be equal to limit n lengths to infinity h constant. Now 1 to n, so sin h plus sin 2h plus sin 3h up to sin nh. Clear? So what I'm doing, I'm taking this series separately. Okay, I'm taking here Sn is equal to sin h plus sin 2h plus up to sin nh. Clear? This is the series. I'm solving it separately and then I will put it here. Now, what I will do, I will multiply it divided by 2 sine n by 2. 2 sine, sorry, I am dividing it here 2 sine n by 2. So I multiply with each term 2 sine n by, sorry, it's h by 2. sine h plus 2 sine h by 2 sine 2h, 2 sine h by 2 sine nh. Okay, I had multiplied it, divided it by sine h by 2. Okay, so now 2ss. What is the formula for 2ss? C minus c. Okay, but in 2ss, when you are using c minus c, first you have to subtract. Formula was like this: 2 sine alpha sine beta cos alpha minus beta plus minus cos alpha plus beta, right? 2ss c minus c, but first you have to subtract it. So I will use the same here, 1 by 2 sine h by 2, clear? This will be cos h by 2 minus h, or else I just rearrange it, h by 2, 2h h by 2, nh h by 2. So it's easy to subtract it. See, divide by sin h by 2, 2 sin h by 2, 2 sin h by 2, 2 sin h by 2. So h minus h by 2, it will be h by 2 minus cos h plus h by 2, 3h by 2 plus, now here again cos 2h minus h by 2, 3h by 2 minus cos 2h plus h by 2, it will be 5h by 2. And the last cos nh minus h by 2 minus cos nh, looks like this, plus h by 2. Okay, now see here what is happening: minus cos 3h by 2 plus cos 3h will get cancelled. Same way, this cos 5h by 2 will get cancelled with the next bracket, first term, right? So when you're solving, finally this will also get cancelled. Clear? Remember, if in this type of intermediate step, if the first in the first bracket first term is remaining, then the last bracket last term will be there. Okay, so this will be equal to 1 upon 2 sine h by 2 cos h by 2 minus cos nh plus h by 2. Clear? So let's take it as 1. So from 1, this will be h upon 2 sine h by 2 cos h by 2 minus cos nh plus h by 2. Clear? So now see this, I am just taking these two here. So sin h by 2, and instead of n lengths to infinity, I can write now. So this is from 1 and n lengths to infinity implies h lengths to 0. So see now, h lengths to 0, sin h by 2 upon h by 2, 1. Cos h by 2, what is h? 0. So cos 0 minus cos nh plus h by 2. What is nh? Pi. And h 0, so it's cos pi. Okay, so now what is cos 0? 1 minus cos pi minus 1. So 1 minus minus plus 1, answer is 2. Clear? Okay, so remember this step. If it is cos x, then also you will use this similar method. Okay, so what we have done here, we have taken this series separately, solve it, 2 multiply divided by 2 sine h by 2, 2ss c minus c. Finally we get here, and instead of n lengths to infinity, I am replacing it by h lengths to 0. So sine h by 2 upon h by 2 will be equal to 1. Remember here it is 2 sine h by 2, so I have taken this 2 here. Clear? And you want to verify, you can directly integration of sin x is cos x, right? So minus cos x, clear integration of sin x is minus cos x. So minus cos pi minus cos 0. So minus of minus 1 plus 1, that will be equal to 2. Clear? Okay, but if it is a limit of sum, you have to solve it by this method. Clear? So just go through this question. Okay, so that's it for today. In our next video, we'll start with exercise 7.9. Clear? Thank you.